Hi everyone, in this new video we talk about the conditional probability. So let's understand what is the conditional probability and what is the bias theorem. So here we have an example. Let's say we threw a dice once and we have two different events. A is getting a number less than 4. So here we have A with number 1, 2 and 3, which is less than 4, and B is another event that is getting an even number. So this is B. We get 2, 4 and 6. And here the question is, what is the probability of A? What is the probability of getting a number less than 4 in this experiment? So we know that the formula for probability is the cardinal of this event divided by the cardinal of omega. Our omega is from 1 to 6, so the total number of possible outcomes. So if I throw a dice, I can get 6 different results. So cardinal omega is 6, cardinal omega is 6, and cardinal of A, how many is the number of favorable outcomes. Now here, how many number that are less than 4 in this experiment? We have 3, so cardinal of A is 3. So this is the probability of getting a number less than 4, 3 over 6, which is half, 50%. Now the question is, imagine I have an additional information. So let's say, for example, if I know that this event is this A, we are looking for a number that is less than 4, but imagine I know information that it is an even number. I give you this information. I tell you this is actually an even number. So here, what the first thing that changed is the notation. Now it's not PA anymore, but it is PA knowing it is B, PA given B. So we must write it like this, because now what I want to find actually is the probability of A, knowing that it is an even number. The second thing I need to change is the omega. So in the first probability, all the possible outcomes are all the result in this experiment, so from 1 to 6. But when I say it is an even number, so my omega shrinks, gets smaller. So the new omega, let's call it omega prime, will be the total even numbers, the number of even number I have. So it is the second event, so which is B. So the new cardinal omega, since new omega is B, so the new cardinal is the cardinal of B. So now I look only on the even number, so which is 2, 4 and 6. As I said, when I have new information, the omega will become smaller, and here our omega was from 1 to 6. When I know it's an even number, it becomes just those even number, so it is B. Our new omega, cardinal omega, becomes cardinal of B. Now here, instead of cardinal of A, I know this, it's not just a number less than 4, but it's less than 4 and at the same time it is even number. So we replace it by cardinal of A inter B. So the probability of A given B actually is the probability of the intersection divided by the probability of the known event. So this is our formula. Again, the probability of A, if we know B happened, is the probability of their intersection divided by the probability of the known event. Also, we can write this is also correct. So the probability of B, if we know A happened, is the probability of the intersection divided by the known event, which is P of A. Now from this, we can get this. So the intersection equals this times this. So it is the probability of A given of B given A times the probability of A. And from here we can get the intersection equals PA given B times P of B. So we can conclude that those two terms are equal. So, and from here we can get this nice formula, which means P of A given B equals this part, PB given A times PA divided by this PB, and that's what we call the Bayes theorem. It is very important and very useful actually in probabilities. So this is Bayes theorem. The probability of A given B is simply the opposite, like the probability, we switch them, the probability of B given A times the probability of A divided by the probability of the known event, which is B. Again, this is very useful and very important. Now let's see some properties. If A and B are two independent events, in this case, by definition of independent events, that means the probability of A given B is the same as PA. So now when B happened, doesn't change anything in A. So the probability of A given B is PA, and the probability of B given A is PB. So now when one event happened, doesn't change the outcome of the other event. And from here, from this that we got, as I said, by definition, we can say that the probability, and from here, so the probability of the intersection is simply, for example, here we know that this one is PB, the same, so it's PA times PB, and also we know this is PA, so it is PA times PB. Now, so from now on, if you know that A and B are independent, so the probability of their intersection is just the product of the probability. So it's PA times PB, like this. Now let's see some other operation. Here the first, the probability of A inter B bar is simply, we saw this in the first videos, so it is the probability of the event that doesn't have the bar, it's not the complement, so it's the probability of A minus the intersection of A and B, not B bar, the intersection of A and B. So we solved this in the first videos and we know how we got it. So you need this property because it is also important. Now the second operation here, the probability of the union of A and B is, we also saw this, so it is the probability of A plus the probability of B minus the intersection. We said that why we deduct this intersection, because the intersection we find it in A, we find it in B, so if we don't subtract once, it will be counted twice. So this is why we need to subtract the probability of A into B. Now P delta A delta B, so this delta is not like the U. This is what we call the exclusive OR. So here, unlike the union that says PA and or PB alone or together, so either A happens or B happens or together. Here, when we use this delta or the exclusive OR, that means either A happens or B happens. They cannot happen together. So it is the same as the union, but we need to remove the intersection. We need to remove the intersection. So we just take this formula minus the intersection again. So it is the final formula of delta is PA plus PB minus twice the intersection. Another property, if A and B are mutually exclusive, that means B is a subset of A bar, and this implies that the intersection of B into A bar equals B, and B union A bar equals A. That means since B here is a subset of A bar, the intersection gives the smallest one here, which is B, because B is contained in A bar, and their union is the largest, which is A here. A bar, in fact, not A, sorry, A bar. B union A bar, and since B is contained in A bar, their union is the largest one, which is A bar here in this case. And another property, if A and B are independent, you have to know that A and B bar also are independent, and B and A bar also are independent. And the last one, the complement of P given of A given B is the probability of actually the complement of A given B is the A given B bar. In another word, the probability of A given B plus the probability of A given B bar, it is 100%, or it is 1. So thank you for watching. In the next video we solve some exercises for practice in conditional probability. So thank you.